Let us talk about pH. So this is a kind of a cool way to view pH. It gives you a practical look at things that are acidic or things that are basic. I think most people are pretty familiar with the idea of pH. pH of 7 is completely neutral. Distilled water with no extra ions in it would be completely neutral. pH of 7. Intercellular fluid and arterial blood are slightly basic. You notice that they put them right next to 7 because they are 7.4. 7.35 to 7.45 as a matter of fact, but they are in fact slightly alkaline. This list gives you an idea that, oh, it's close enough to 7, it's basically neutral. That is not true. Every deviation of 0.1 away changes things considerably, especially for biological mechanisms. So 7.4 is quite different from 7 as far as the sustainability of life. Okay, but anyway, it's pretty close to 7. I would describe our blood as alkaline. I would not describe it as neutral by any means. Okay, then you go down the list here. We got baking soda at 9, bicarbonate of soda at 12, sodium hydroxide at sodium hydroxide, NaOH, at 14. So that's a very, very high number, which also means a very alkaline or very basic substance. On the other side of the scale are things that are even more familiar: coffee, urine, coffee, tomatoes, lemon juice, and stomach acid. Hydrochloric acid is the most acidic thing that we have, so a number that is very low as we go from 7 to 0. These are very low numbers, but very high acidity. All right, so what do these correspond with? What pH is the negative log of the concentration of hydrogen ions. That's the definition of pH, the negative log of the concentration of hydrogen ions. And so if you look at the other side of here, this lists where we actually get the pH number from. At the top here, we have the concentration of hydrogen ions. That little H plus means hydrogen ions. The brackets around there is a little shorthand that means concentration of. And so what we're saying is that we're looking at the number of hydrogen ions basically in a substance. 10 to the minus 14, although the number is very high since it's a minus 14, is a very, 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 very low number. 10 to the 0 is 1. 10 to the minus 7 would be 0.00000001, if I counted the zeros correct. Basically, you count the number of zeros back, and that's the concentration. So the higher the number, if it's a negative log, you see, the higher the number, the lower the concentration actually is. So if you have something that is a pH of 14, it represents 10 to the minus 14s. It means it has an excessively small number of hydrogen ions. Conversely, if you have a pH of 1, it represents 10 to the minus 1. That is an excessively high number of hydrogen ions. Either situation is extremely difficult to survive. Either things that are very, very alkaline, extremely low hydrogen ion concentration, or things that are very acidic, extremely high concentration of hydrogen ions. Both are basically equally devastating for biological function.